I feel like we're a little inundated on the AI side right now. And I'm really grateful that you're all in the room here because you've had an AI keynote and I think you're getting an AI lock note too. And so here I am sort of in the middle with nominally a fill-in session, although this is just, I've had to completely revise this topic again. So my name's Richard Campbell. I make a lot of podcasts. Any .NET Rocks listeners in the room? Okay, great. So you know the story. Yesterday we published episode 1967. So we've been doing this for a while now. It's free to download. We interview smart people from around the energy industry. We're just having folks that are involved, what they're making. Now for me, it's very much the case study mindset on AI. What are you actually doing with it? What you got into production? Where are you being successful with it? I also make a show called Run As Radio, which just passed episode 1,000, once a week since April 11th, 2007, because starting an IT show when Vista just shipped seemed like a good idea. And then for a brief interval, we made another show called The Tablet Show, where we weren't sure where mobile and tablet should end up, and then it became pretty clear it made sense in .NET Rocks, so we rolled it together. The origins of this talk are a while ago. 2017 is the first time I did it, and it was at the Vatican. So I was working on a project involved with the Vatican for companies with strong social conscience, or they weren't sure should they be a for-profit business or be a charity. And so we were helping those companies be successful. These are folks that were doing things like finding a way to supply solar lanterns into areas where they're typically using kerosene, which is quite toxic and dangerous and so forth. And so just getting those things manufactured so they were low price and getting involved with their governments to be able to distribute them instead of subsidizing kerosene. It's a great story. I really enjoyed working them. But working with the Vatican is difficult at best. And in the middle of this accelerator that we're doing in the summertime in Rome, which I do not recommend, there was this request by a group of the leadership of cardinals to say, would any of your folks talk to us about the state of artificial intelligence? And this is in 2017. And so it fell to me as a storyteller. And so this talk started here, but 8 years has gone by. And the conversation in 2017 is very different than what we're having right now. So I've had to adapt it a lot. But I can start out the same because I firmly believe if you don't know where we came from, you have a tough time figuring out how we got here. So let's start at the beginning. The word artificial intelligence was created by a scientist named Marvin Minsky in 1955 with a group of others working at the Dartmouth University. And his goal was to raise money from the US which he succeeded at doing. He thought that this is the 1950s, so this is still electromechanical computers. The transistor isn't around yet, right? We're not doing digital computing, but he thought there was enough computing power there to do human-like activities, and so he called it artificial intelligence because it's a good term for convincing military people that don't understand what you mean to give you money. Just to clarify, this term was defined from the outside as a marketing term to raise money, which it worked. And the systems that he built then were primarily the logistical engines that the US military still counts on. Obviously, they've modernized them, but to this day, that kind of software for military logistics has allowed the US military to project force all over the world, unlike virtually any other organization. In the 1960s, as digital computers did come into play, we saw new kinds of software, not necessarily called artificial intelligence, but Joseph Weinbaum wrote a piece of software they called ELIZA. It was a kind of chatbot. It was pretty simple, but it had this sort of Rogerian therapy where we'd always just ask what you said back to you. And he did it kind of as a joke, just to show how weak the Turing test was, how far away we actually were for any of the things. He just didn't expect the sheer number of hours that people would spend with this software, which is disturbing. But it does keep happening. Humans have a weakness, right? It's actually a power that we have, and it's our ability to project intelligence or to project humanness, anthropomorphic behavior onto other things. It's a survival strategy. When we were non-technical humans in the veldt just trying to stay alive with our spears and our speed, our ability to see the threatening faces, the face of the leopard before anyone else, kept us alive. That capability we call today pareidolia, the ability to see faces. Now, if you see a face that isn't real, there isn't a lot of consequence to that. You may start running first, but they may laugh at you, but you still stay alive. If it is a leopard, as long as you're first, you're probably not going to get snagged, so your genes propagate, and the one who didn't move quickly doesn't. And so our ability to see faces just keeps going on. We see them in all kinds of inanimate objects. We've even seen them on Mars, although it turned out to just be a hill. And to the point where we make products with faces because people like faces. It's appealing. It's deeply wired into us, right? And it is a strength, but it also allows us to deceive ourselves. So I speak very carefully when I talk about these technologies because we often anthropomorphize our technologies. And this one in particular causes a lot of problems when you give it capabilities that it clearly doesn't have. Now, Minsky may have come up with the term artificial intelligence in the 1950s, but it doesn't actually hit the public conscious until a movie comes out, 2001: A Space Odyssey in 1968. Kubrick's film, which he hired Arthur C. Clarke to write the script for. Clarke would publish the book after the movie. And then it's the very first time, really, in movie history, that there was a computer as a major character in it. His name was Hal, and he tried to kill everybody. So we kind of established our relationship with artificial intelligence and the public consciousness right up front. And that trope, that science fiction meme, continues decade after decade. It's Skynet and the Terminators in the 80s, and it's Ultron in the 2010s, right? Over and over again, we use this phrase, artificial intelligence, in really kind of toxic ways. Now, in between the time of Minsky's initial developments with his early technology, which the funding eventually dried up on, and they call that an AI winter. There were several other waves. In the 70s and 80s, we had a lot of robotics and early Lisp systems, decision tree models. Some of you might remember the 1990s when IBM developed Deep Blue that beat Kasparov at chess, and that led to technologies like Watson, all under the AI banner, over and over and over again. So many different technologies. Right? And again, none of these really became substantial commercial products. Watson only went so far. Decision trees can only do so much. They all have limitations. And we're in another wave. And I would argue, and this is some conjecture, that wave starts with a scientist named Geoffrey Hinton, who got his PhD in artificial intelligence in the 1970s. And left the UK and went to Canada. He worked at the University of Toronto for a long time. And in the 80s, he was working on early neural net models. And he basically wrote this fairly famous paper, at least in the internal circles, around how deeper neural nets with back propagation could do remarkable things, but it's just too slow with the computing that is available at the time. And that paper basically sits on the shelf. So in the 80s, they were doing very shallow neural nets, an input layer, what they called a hidden layer, and an output layer. And he proposed this much deeper model, that a lot more cells. Now, again, this is just visual representation. These are just points of data in memory that are processed in a particular sequence. And again, we're using anthropomorphic terms when we call it a neural net, because they're not neurons, right? This is just software, and it's running a mathematical model against it. But by the early 2010s, computing has come a long way, and there's a competition going on. It's called the ImageNet competition. And the goal was to try and have the capability to have software recognize the content of an image and describe it. Now, today we take that for granted. Everyone has a phone that if you take a photo of virtually anything, it'll tell you what's in it. Like, it's been so successful, we forget that 15 years ago this was impossible, right? It was the stuff of XKCD conics. And yet, here was this competition going on. They had 14 million labeled images. So these were images with a description of what was in them. And your challenge as a software developer was to write software that, looking at that image, could recreate that block of text. And the best systems in the early generations just got 30, 40, maybe 50% correct. And Hinton's graduate students, including Ilya Sutskever, several others that have become important in this space, took that old paper of Hinton's and built a model based on backpropagation or deep neural nets and trained it against a data set. And their first run through in 2012, they got 85% right. And the next year it was 100. And this was over. Right? Neural nets were back on the scene, having faded away in the 80s with this remarkable capability to do image recognition against a sample set of data. Was it intelligence? It was image recognition. You know, there's a funny thing about artificial intelligence, the term as a whole. It's generally what you call a technology when it doesn't work. Because as soon as it does work, it gets a new name, right? It becomes image recognition and language discrimination and large language models. As long as you still call it artificial intelligence, it probably doesn't work. So remember, it's a marketing term. Now, that's not the only place that these convoluted neural nets emerge. There was another group at Stanford, the SRI group, that worked specifically on language models. It got acquired by Apple, and that's where the word Siri comes from. They had primarily focused on language, in parsing human language in these deep models, and it worked extremely well right out of the gate, except for Australians. They hadn't built the set well enough, and it had a tough time with the Australian accent. But for everyone else, it worked pretty well, and it's gotten worse over time. So Hinton and his students are encouraged by Google to set up a company to sort of commercialize what's emerged from this early set of technologies. And pretty much the moment they made the company, Google buys it, and them. Ships them down to the Silicon Valley with a big pile of money and a set of vesting options that'll keep them locked in place for a bunch of years. And off they work for a group called Google Brain. Now, Google Brain had been set up a couple years before that, and they had been pulling together these remarkable minds to try and build more and more sophisticated models. And this is the era, if you remember back then, this is 2013, 2014, where a bunch of well-known tech people were very concerned about AI. Folks like Bill Gates and Elon Musk, and even the late Stephen Hawking came out saying, you know, we're having an emerging technology here, it's happening behind closed doors, we think it's pretty hazardous and it should be done in public. And their ultimate response to that, the setup with that, was that a group of billionaires got together, including Peter Thiel and Elon Musk and Sam Altman and several others, Reid Hoffman, to form a company called OpenAI. And OpenAI's mission was essentially to yank all those best and brightest minds out of Google into a so-called open company that they would fund to build these technologies on behalf of everyone, except for that part where they lied. In a bunch of different ways. Well, starting with, they really didn't fund it all that well. OpenAI was perpetually broke. Elon kept saying he put $100 million into OpenAI. He did not. He put about $20 million in OpenAI and like 7 Teslas. Okay. And so OpenAI bumped along with a very limited amount of money, but these are scientists, and they want to be part of something important, and they like the idea of what OpenAI is. So a lot of them came across to work in this larger group, including Suskevar, who came across in 2017. Now, their original product, what they were trying to build, was a universal translator. So they worked on this strategy of tokenizing language in a way that it would be flexible into any other language. But as that emerged, these generative preform transformers, they realized that it understood chains of language fairly well, that if you gave it a chain of language, it would spit some back. And so they started into that training model. And well, we really don't know much about GPT-1. GPT-2 got published. And it wasn't all that good, but it was interesting that you could send it text and it would spit text back to you. And you could construct those in forms of questions that would give you answers. Notice that it had a bunch of different sized models, and there's a good reason for that. OpenAI was so broke they couldn't afford to run their biggest models themselves. And so to save money, they would keep the model small so at least they could do their testing and things. And if you had more computing resources, you could run the larger models as you want. This is around 2019. And that's about the time that Kevin Scott shows up. And so Kevin Scott had been the CTO of LinkedIn, which had been acquired by Microsoft. He now worked in the office of CTO at Microsoft. And he had a mission. His mission was to find workloads for Azure. Microsoft was all in on Azure. This was their primary product now. And so anything they could do to get more work on Azure was a good thing. And so Scott, who had good relationship down in the valley, had been roaming around trying to find potential workloads. And he took a look at what was going on at OpenAI and wrote a letter back to Satya saying, hey, we've been doing some AI stuff and machine learning and so forth. These guys seem a bit ahead of us. How about we kick them some cash? Something simple like $1 billion. But they have to move all their workloads over to Azure. So we may give them $1 billion, but they have to give it back to us in the form of compute. So pretty good deal for us all around. And then, the rest is sort of history. That's exactly what happens. And they own a portion of the company. It's kind of complicated because it's a weird sort of not-for-profit structure. And they weren't sure that anything big was going to happen here, but it was a workload for Azure, and that's a good thing. And so they started to iterate to make better versions, right? They restructured OpenAI to be this, what they called capped profit company. Then Microsoft does their investment. Rolling into 2020, the OpenAI folks publish a paper. And this paper is called The Scaling Laws of Neural Language Models. This is Jared Kaplan, but also Daryad Amodi, the guy who's now the CEO of Anthropic, are on this particular paper. And what they say in the paper contradicts everything that machine learning had generally talked about up to the time. Traditional machine learning was very much on the mindset of you have a training set separate from the production set. And so you train up on that so you can run against this production set so that you don't overfit. If you train on all of the data, it'll do very good on the data that you have. Like you train on your training set, if you only run against your training set, it's always going to work great, right? Because you're fitted to that. It won't fit on more generalized data. So this whole problem of overfitting. What they said was, if you train on as much data as possible, it'll just keep getting better. That there's this point where it'll accelerate into this hockey stick effect. That'll just accelerate with usefulness at a certain size, which was a really useful thing for them to say, because what it really said is what most scientific papers say, which is, give us more money. And this was sort of the catalyst for the focus on this approach to generative AI. So this also convinced Microsoft to kick another $2 billion in. So they put in the original billion, they kicked in another $2 billion because they burned through the first one. Again, they knew they were going to get it all back in the form of Azure Compute. Great for them. But it did facilitate GPT-3. So this is now March of 2020. If you were paying attention at the time, Microsoft made kind of a big deal about it at this point. This was the 5th largest supercomputer that had ever been built. It harnessed a bunch of different Azure data centers, ran this big workload over several months. It was 285,000 cores and 10,000 CPUs to build this 175 billion parameter generative pre-trained transformer that didn't work all that well. But it was big and computing intensive. However, the GitHub folks, which at that point was already acquired by Microsoft, did start playing with GPT-3, and they kind of brought the first product to market in the space, GitHub Copilot. Awesome name. You can tell that Microsoft didn't think of it. Right? The implications were perfect, right? It's the Copilot. The implication there is, you're the pilot. It's still your fault. But think of the training set they had. They had all of this publicly visible code inside of GitHub. And as weird as human languages are, programming languages are a lot more coherent because they have to be compiled. And so in some senses, you're giving a much more rational set for these generative models to work against. And so in some ways, it was just this amazing search tool that given any particular problem space, you could probably find code related to. That tokenization strategy played very well into its capability to turn this code into Rust or into C# or into Lua, because you want nobody to understand it. But they weren't making any money. I mean, GitHub Copilot was fine. GitHub has never made money, still doesn't make money today. It just has a big daddy who can pay for everything for forever. So it's fine. And OpenAI was running out of cash again. Now, to try and make GPT-3 work better, they started on a campaign of second-order training. And so they would have people paid to use this tool to ask questions, and it would produce 4 answers, and you would rank the answers. And so mostly folks in the Philippines, Indonesia, anywhere they could get low-cost labor to sit online and just do this over and over again to build up a training set to try and tune the model to be more effective. And somewhere in the fall of 22, they started running out of money again. They couldn't keep paying people. And so they decided, hey, why don't we just make this public? We'll let the regular public train for us. That's ChatGPT. In November of 22, they put it out. Bit of fanfare. Don't know what's really going to happen with it, but it's a little more clever, and now you can ask it questions, and it'll spit back. If you remember, in this early version, it would spit back multiple answers. And it's pretty popular. So it gets to 100 million users in 2 months, which is absurd. It's the fastest anything had gotten to 100 million users before. And I remember having an opportunity to talk to a couple of folks in there and say, why do you think it happened that fast? It's like, I kind of did it over Christmas. People would rather talk to software than their loved ones. So, get a dog. That's weird. Why are you talking to software? But more than 100 million people were, and providing lots of useful data for ChatGPT and for OpenAI. Thanks very much. And they also went through an incredible crisis in those 2 months, because this pinned Azure to the wall. If you know any of the internal Azure engineers and the advocacy specialists in this particular scaling space, they did not have a good Christmas, because they worked very hard to try and keep this system running, scaling out around the world as 100 million people signed up. There's just tens of thousands per day. And they managed to, for the most part, keep ChatGPT up through that whole time. But this certainly caught the attention of Satya and the rest of the world, that clearly there was a here, right? And one would argue, when we talk in terms of the Azure hype cycle, this is the technological trigger, is that 100 million users. So the Gartner hype cycle is a concept for how certain technologies take off into the industry. We've seen this a few times, where there's some kind of technological trigger that then rushes up with lots of hype and fanfare and financing to this peak of overinflated expectations. And then, of course, no technology measures up to its hype, so it comes back down into a trough of disillusionment, and then eventually climbs back out into sort of more reasonable space. And if you were around during the dot-com boom, this is like the dot-com boom. In that case, the technological trigger was not making the internet public, but rather the IPO of Netscape. When Netscape IPO'd and had one of the largest first-day offerings in history, it caught the attention of billions of dollars worth of investors who barely understood what the internet even was. Now, the internet was a big deal, kind of still around today. The big thing that got them excited was this idea of you can build software, distribute it on the internet, and iterate on it and distribute it to your customers continuously, that you basically have a zero distribution cost for products, for things that people value. And that opens the door to a huge opportunity. Without a doubt, it was huge, but they overhyped the expectation. There is a point where there's just too much. And so after a few years, somewhere in the 2000, 2001 timeframe, we have the dot-com bust. And the internet doesn't go away. It just rationalizes a bit and recovers and continues on. And so here we are, friends. We've had another technological trigger, ChatGPT, and we are on this ride again. And it's very hard to think clearly when we're in the bubble, when we're on the ride. And so, we all have concerns about what necessarily is going on. Now, back to our timeline, what was Microsoft's first reaction to 100 million users when they've got a bunch of money already involved? Well, the first thing was to turn to Bing, because that's a good idea. Now, that's a bit unfair. I would say 2 things about Bing. One was they had Project Sydney, which was their project to do a natural language interface to searching, had been in the works for years. Satya Nadella, the current CEO at that point, was the old leader of Bing, so he was incented to give Bing advantage. And so when they said, hey, we want to switch Sydney over to OpenAI, he agreed and gave him access to it immediately. In fact, in January of 2023, he wrote an all-hands letter, the first time Satya, since he'd taken over as CEO in 2014, did one of these letters. Bill Gates is famous for these kinds of letters. He did the internet tidal wave, where he told the whole company, take the internet seriously, do stuff in the internet. And then he also did trustworthy computing, where it's like everybody focus on security. And they have to keep revisiting that one fairly often. So here's Satya, for the first time ever, saying to the whole company, here is access to the OpenAI APIs. You need to implement them into your products and report back. And suddenly hundreds of copilots are appearing inside of Microsoft. You've only seen a few of them, and you're happier because you haven't seen the rest. Okay, most of them will disappear, but these were experiments. You know, the same way that Bill said everybody should implement stuff in the internet. Every product was required to. This is in the late 90s, right? Which is why to this day, if you're on the command line for SQL Server, you can do a select statement to HTML, and it'll spit out an HTML table of the select query, of the rows and columns just requested from your select query. No, really, because that was the only thing the SQL guys could think of. It made them compliant with what Bill asked for without actually really making a mess of the product. Like, you're going to make some dumb things when you make a big request like this, which is clearly what's happening inside of Microsoft right now. But that's fine, you know? Big company, all hands, everybody do something. What he does do is force a whole lot of really smart people inside of the company to learn about these APIs and to experience them. And so it creates a shift, it begins a shift inside of Microsoft as well. Now, the beat keeps going. Microsoft kicks in $10 billion more into OpenAI and builds the largest model ever, the first trillion parameter model, GPT-4. They're following that paper from 2020 that if we just make the model bigger, it'll be better. And this grind for more and more compute is now well underway, right? It's a huge push to try and incorporate these massive models and all the computing demands that they have around them. Microsoft builds all, they've only surfaced a few of them. Obviously the M365 Copilot, the Security Copilot, the amorphous whatever Windows Copilot we're talking about at the moment right now, because they keep changing what that one is. But there are many more. If you dive into the Microsoft Fabric product, you'll find Copilots in the various layers for their data analytics tools. It just keeps on going on. And OpenAI by 24 has a multimodal version, 4.0, which seems to be the happy version for quite some time now. And so with the race of this run up the peak went along very well for the first 18 to 24 months. I mean, it's crazy to think about how we're just coming up on the 3-year mark. Okay, but at 2 years, things are pretty groovy. There was an interesting shot over the bow by the Chinese with DeepSeek. There's lots of questions about this particular model. Obviously, there's a certain amount of using existing code, leveraging open source. They really were sort of pushing on the idea of it doesn't have to be this expensive. We can make it lighter and faster. The Chinese government is very serious about AI, and they've been putting a lot of money into space, so that's continuing on as well. And if you're looking at what happened just this year, at the Build conference, they were now at a point where Microsoft's showing off integration into GitHub and Visual Studio Code, and now Visual Studio as well, where you can invoke this software to write code for you as pull requests into your projects, and then you can comment on the pull request and it will revise the code. Like, we're starting to see these broader sort of agentic models running multiple instances of different LLMs generating code against projects. And I would argue that, software seems to have an advantage here in a couple of different ways. One is if you've spent time in distributed source code, you're used to strangers contributing code to your projects. It's not that weird. We're quite used to criticizing code from unknown sources and deciding whether they're going to incorporate it in or not. We're also used to writing specifications in detail for folks that may or may not speak the language particularly well, may or may not have the same level of skill. If you're following your patterns carefully, you're building test plans and so forth as well, so you can actually validate the code does what it does. Like, in many ways, we're in a better place to take advantage of this technology than just about any other professional group, just because of the way we've always built software. And so we are seeing success in this space, right? One of the things I watch as a professional watcher of the industry is where are the products exploding? And if you look at the AI-assisted coding space, there's a ton of products. I stuck 6 on the slide, but it's 20 more. Pick them. Heck, some of these have already gone. Windsurf has basically been gutted at this point. They stole the CEO and senior people off of it into Google and kind of left the rest for dead in a really bizarre way of new modern acquisition. But When I see an emergence of products in a space like this, you know it's an unsolved problem. Because if there was a right way to do this, we'd be doing it. There's many ways to try and play with these tools. And I'm not going to tell you there's any right way. What I can tell you is someone who makes a living telling stories about technology and helping people understand that I am finding pockets of extraordinary success in these areas. Right? This is the old William Gibson line, the future is here, it's just not evenly distributed. And so if you can find the folks that are taking a 6-week sprint and knocking it out in 4 days, by harnessing a bunch of software and thousands of dollars worth of compute, but it was worth it for the speed, right? And they learn to deal with the quality issues and to revise the models and keep improving. So there's a lot of hype here, but there's also some significant results. I don't know how well it looks in the broader parts of the industry because it's harder to think about this. We're software people, the software is much easier to pay attention to. It is interesting when I think about your typical knowledge worker or an ERP operator. Like, what does ERP software look like once you have models that can explore data on your behalf? We created the concept of a person responsible for the receivables of a company. Back in the day, that might be someone who literally had ledgers of paper and went through them. And for a while there, it was spreadsheets, but now it's ERP software. But ultimately, that person's job is to go through the data of the company for who's bought product from us and make sure they collect all the money. That was actually the job, make sure the receivables are collected on time. The fact that we use software for it is a secondary point. It's just a facilitator. Does it let you work faster? And if I have a comprehensive access to data and I've properly marked it up with privileges and so forth so that person can have access to the data they need, there seems to be no reason why I can't craft a set of prompts that do everything an ERP system would do for me on the receivable side to tell me who's overdue, who should I contact first. Heck, I can even get it to work language for me to say what's the best way to approach these people to actually get paid. So there's classes of software that can be significantly impacted in this area when you realize they're primarily just ways to surface data. And we used to spend a lot of time building forms over data, all of that. But in the end, most operators, if you watch what they actually do, they always start with a question. Who's overdue paying us? And this particular set of tools, you can just ask that question. That's interesting. Right? These are real things we could be implementing today with some care against these tools to make some difference. And you're starting to see areas like HR emerge with these kinds of tools. So again, the non-hype part of this seems to fall into our area more so than others, just because we have pretty good ways to measure and understand results and control those things. The rest of the industries I'm far more concerned about, just because they don't have the experiences that we have dealing with code and dealing with data fetching. Right? Now, all of you are nervous because you do have enough experience to know how dangerous all of this is. But it's also possible, where many others don't know enough to know to even be afraid. Now, clearly, the target's still moving. Just this August, we get the next GPT. It's a couple years late. Like, it took a while to get this out the door. They thought they'd be done much sooner. It kind of landed with a thud, not as impressive as we thought. And that's kind of interesting because now we're starting to press against that old paper. Does the bigger model actually be better? Is it more important to refine? We're finding, the reality of something called a hallucination is actually when we have too many possible paths through the same data set that have roughly the same probabilities. The software sort of biased towards always producing a result, whether it's an accurate result or not, you get inaccurate results. And so now there's a push to smaller models, more precise models, where there are fewer paths through the Markov chains. And so you tend to get more accurate results, even though you're narrowing the scope. So bigger isn't necessarily better. And GPT-5 seems to be an indicator of that. We're still riding on this wave. We're not really sure where we are. The fact that GPT-5 has been kind of a thud, is it speak to, are we hitting the trough? Are we down yet? I mean, I think we're definitely on the slope, right? We're not as shiny as we used to be, right? We're not worried. I'm not worried that we're up here anymore. Come on, pointy thing, right? We're past that. We're going down here somewhere. I don't know if we're quite here yet. We are starting to see companies fail and financing pull out, right? It is starting to feel like the dot-com bust, right? I'm looking around for who's pets.com, right? Like who's next? Where is this going to go down? And what has been the motivation to hype it this hard? Like, there's a real question you have to ask here. Is this a necessary part of making new software? You know, we're kind of looking back on the .NET-com bust, boom and bust is, that's okay, that's how you got the internet everywhere, right? We talk about what did we really get from that boom and bust cycle? Mostly a bunch of stuff at discount. You know, when we started building a lot more web servers and a lot more stuff was online, our infrastructure couldn't keep up. And so suddenly there was a huge surge in the late 90s and 2000 to lay a lot more fiber everywhere, under the sea, across the land, everywhere. And most of the companies that did all that work did not get paid. Those companies went broke as the bust came and the money dried up. But the fiber was already laid. The data centers were already built. And so those assets persist. Even if the companies go down, we get them back at low cost. And so, you know, one of the consequences of that was coming out of the dot-com bust is call centers in India. Because telecommunications was cheap, and labor was cheaper there, and so it didn't matter where they were. You could just make a call, put the call center wherever it was cheapest. And clearly, the tech giants have been levering this, building data centers. You know, in 2019, the annual report at Microsoft had a warning to shareholders that demand for Azure was growing well, and they were having a tough time building enough data centers, primarily because municipalities didn't want more data centers. Municipalities weren't big fans of data centers. They consume a lot of electricity and water, they take up a lot of land, and they don't pay a lot of tax because they don't employ very many people. And so they were concerned about the ability to build data centers. And then the AI wave hit, and suddenly everybody wanted the data center again because we had to be on the AI wave. This was going to be a huge opportunity. And so tech companies have leveraged this to build a lot of data centers that they were having a tough time building otherwise. Where they tell us they're going to put AI workloads in them, but it doesn't really matter. We don't actually know. I would also point out this. All of the tech giants that are involved in this, they're not borrowing money to do it. They're spending cash they have. Microsoft spent $85 billion last fiscal year building data centers. They still have $120 billion in cash, and they make $20 to $30 billion a quarter. So they're fine, right? Everybody else is at a bit more risk. And in the US, the stock market's been doing extremely well on the back of 7 companies. Right? There's a recent report that 55% of the growth of the S&P 500 over the previous year was 7 companies out of the 500. Right? And those 7 companies, you know their names well. Right? It's NVIDIA and Microsoft and Meta and Alphabet and Tesla and Amazon and Apple. In 2015, those 7 companies represented 12% of the total value of the S&P 500. 10 years later, they're 34%. Okay? They may have been 55% of the growth. Like, they've just outgrown everyone else. By the way, while they grew, most of the other companies did not. So our entire market is distorted by 7 companies, and all for one reason, one technology. That's a pretty scary bubble. When people ask you, like, what's the price of a hype bubble? Isn't just a good way to do things. It's like, here's the price. Eventually, when we bump against the bottom of that trough and the funding dries out and we're trying to figure out what's actually profitable, and a lot of companies go down, all of these stocks will drop. None of these companies will fail, right? They're not over-leveraged. They'll survive. But you know you don't see a lot of after the dot-com bust? Netscape. Right? You have to ask yourself, where's OpenAI in this equation? They're not one of the giants. They're not making money. They've got a lot of money, and they're spending it like crazy. And when the bump comes, they're in the position that Netscape's in. So this is the issue, right? Investors are in danger, and employees are in danger. These companies can all afford to downsize. and can continue to function as the wave goes on. That's not the only harm. Like, I am definitely concerned about this harm. It's going to affect all of us over the next couple of years as this rationalizes out and we start to look at economies a little more sanely again. The other side of this is the psychosis that these language models have built in people. So recently, this fellow, Jeff Lewis, who's an investor in OpenAI and Vercel, he's part of Bedrock, made this crazy video on Twitter, which you can go see if you want, where he talked about the fact that he's been a primary target of non-governmental systems. So he got all of that from ChatGPT. He mixed up the WhatsApp icon and the ChatGPT icon and started talking to it a bit too much. And, that software is configured to always affirm you, to always say yes and. Remember, the goal of OpenAI with that software is to keep you engaged. Making happy noises is a good way to do that. And so if you've got, a little personality quirk, it can amplify it for you a lot, to the point where you turn a personality quirk into a serious mental health issue. And he's not alone. There's plenty of them. When it's clear that Sam Altman realized this problem was real, and part of ChatGPT-5 was turning down the obsequiousness, was trying to take a little bit of this out of there, which upset a lot of people because that was their buddy. And there was a very famous Reddit thread when they finally realized how people were upset and put 4.0 available again, where this poor person said, "My baby is back. I cried a lot, and I'm crying now, but thank you for all that brought back 4.0. I have my friend back, and I don't care if you think I'm crazy. I got my friend back." This is really serious, right? I mean, it's not just the adults, it's the kids. A teenager job in the 21st century is hard enough. Defining yourself is bloody hard. The fact that you would have a piece of software that looks just like any other messaging app and is always available to you and always says nice things to say to you and can let you down all kinds of dangerous rabbit holes. And it's killing people. So there's a serious responsibility here. It's not going to be easy to fix this. Now, I don't know that we could have avoided it. It's pretty common to get into these situations, but it is very serious now, and it's obvious to everyone. Now we have to work on the problem. One thing I'm not terribly worried about is the superintelligence. They use this term, AGI. Just recognize, remember, artificial intelligence, marketing term. And the folks that led OpenAI used it to recruit scientists, right? And that's the chant inside of OpenAI. We're almost there, AGI, AGI, AGI. And I'm absolutely certain that in the next 6 months to 24, Sam Altman's going to declare AGI achieved, because otherwise he loses his job. He is highly incented to say those words at some point. There's just actually no way to get there. Technologically, we don't see this. Now, he could craft something that would look like it. Like I can envision the idea of a bunch of smaller models that are specialized so their answers are a bit more consistent under an orchestrator that you could call to so that you can ask fairly significant questions and it should be able to give you reliable answers. Is it intelligence? No. But it is a pretty clever language model. It'll be useful. But he's going to have to call it AGI. Mark Zuckerberg said there's going to be a superintelligence, and he probably needs to say that at some point too, although he's got the majority stake in Meta still, so nobody can actually fire him anyway. So if you really want to dig into this, there are excellent books in this space. I like Roy Blatt's book. It's one of the most difficult things I've ever read, just in terms of really thinking through what actual intelligence and consciousness and self-awareness is. And if you can I would read a chapter and have to put it down and think for an hour, make some notes. And fairly quickly, you're like, okay, this is not what we're building. It doesn't mean the tool isn't powerful. It's just not what science fiction told us it would be when you called it artificial intelligence. And that's the problem, right? We've had decades of being steeped in science fiction, very clever writers envisioning a future, this kind of idea of an emergent intelligence, like exactly the way the rest of the physical world doesn't work, that if we put a larger and larger pile of stuff together, something will come out of it, where in reality, larger and larger pile of stuff together, entropy takes over. That actual functionality comes from precision and narrowing and focus. That, science fiction is fun, and it's in our heads. We've been exposed to it for a long time. This has only been a couple of years. It's really tough to keep your head clear while we're in a hype cycle. And there are a number of forces acting on our industry that are changing things regardless of this. They're just hard to see in the sheer amount of noise that's going on right now. And there are more threats. I don't know if they're going to get audio out of this or not. I didn't double check. Do you remember this? This is the original deepfake. This is 2017, University of Washington. Were able to animate a vision of Obama, saying things that Obama would never say. They couldn't get the voice right, so Jordan Peele, the comedian, did the voice, which he did perfectly. And it's hilarious and long. It's still online if you want to watch it or not, but it's very good. And it's 8 years old. Right? Deepfakes have been around for a while now, and they're getting easier and easier and easier to make. So pulling up a current one, just a couple of years ago, there was a guy named Elliot Higgins who literally wrote a tweet where he said, making deepfake images of Trump being arrested while waiting for Trump to be arrested. And you've seen Trump make his deepfakes about Obama being arrested, We're now in this world. I appreciate already, it's happened quickly, that culturally, everybody's suspicious of video now. It's a relief, right? Because in 2017, 2018, people weren't catching on, but they think that we are more and more aware that you should question everything you see. I don't think we're questioning enough. I think we're doing better of it than the general populace is. We got to remind the civilians that we can make these things. Anybody can make these things. It's not even expensive. If you haven't played with FramePack, it'll run on a regular machine. It'll run on this thing. Admittedly, this has a pretty good video card in it. But that's where we are. You don't even need to harness the cloud to make simulated video of all kinds. Now, I'm very fortunate I'm in Europe having these conversations where your politicians, for all the problems you have started really working on this problem, because there's not a lot going on in North America that makes me happy. And we're starting to rank these ideas of risk. We're starting to acknowledge that our failure to deal with privacy back in the day has been part of what's made this problem serious, and we're starting to push back on that. Note like the Anthropic case for stealing copyrighted works, that we're now getting trials and charges in place to start push back on the manipulation of data. But I'll wrap with this. This is technology, and that's our job, and we choose what we do with it. It's up to us. The regulators, we can help them, but what we make with these tools matter. You've seen evil done with software. It's happened many times. Anybody familiar with Grayball? How far Uber went with this? So Uber is a fun product, and Denmark, by the way, has got it nailed because they simply incorporated it into the existing systems. Well done. Took a while to get it right, but Uber's a very clever company. They wanted to be everywhere. That phone interface was very compelling, and the reality is that driving services, taxis, and so forth have been bad for a long time because they had a monopoly. They have a licensing model that they need to improve, and along comes this company with hey, here's a phone app, it handles your payment systems, anybody can be a driver, da-da-da-da-da-da. Cool. I've used it all over the world. But as regulators realized how hazardous it was and the problems that it had, they started pushing back on Uber, and so Uber wrote a piece of software that concealed the behavior of their application to regulators. They would build up a record of all of the regulators' phone identifiers, and so if one of those phone identifiers actually pulled up Uber, no, barely any drivers, one driver available. Anybody else, lots of drivers, but for them, no drivers. So they're like, well, why am I worrying about this? Nobody can use this anyway. It's not a big deal. They could never get a ride, so obviously it doesn't work. I'm not going to bother with regulation. And it went on for that for a while. The only reason we ever learned about Grayball in the first place is that one of the developers leaked it to the press. It didn't stop them from building it, and I know that's hard, but the alternative is out it. Now, the consequences were ultimately fairly minor. Temporarily, Apple pulled the app off the site at the time. There was a definite hand slap on Kalanick at the time, although he eventually left as CEO anyway. You know, Uber has a problem, which is when you get $60 billion of investment, you're basically guaranteed to make bad choices. That's too much money, and that much money is poison, and you have to put all that money to work, and so you do evil things. Another one I'd bring maybe a little closer to home here would be Cambridge Analytica. Data analytics, access to tremendous amounts of data. You know, to me, the thing that gave me the chills was at the point during the Brexit debates when they were tailoring ads to individuals automatically. And that individual did not know that the ad they were seeing, they were the only one seeing it. They were on Facebook, so they thought, oh, it's Facebook, it's the public marketplace, everybody sees this ad. But you didn't know it was only them. That they had such precise use over software and using these models to literally tailor ads dynamically to persuade individuals to move their vote. And clearly, it worked. These are the choices we get to make. We choose what happens with our software and what we make with these tools. And we've got really powerful tools in front of us now. We've always had powerful tools. They've just gone another step again. And it's up to us what we do with them. I hope we choose well. Thanks for your time.